Okay, so today we're going to be going over max and min using Lagrange's multipliers. And so to start off, we have this function right here, f of xy lambda is equal to f of xy plus lambda times g of xy. And so obviously, in this case, we have our function and then we have a constraint. But what is a constraint? So we have the maximum and minima. We need to find these. But to do so, obviously, we have to find the derivative and that process. But it can't just be any number because we have this constraint. So from a certain point to another certain point, we need to find those max and mins. And so in this case, our function here is going to be f(x) of y, or f of xy, is equal to 6x squared plus 12y squared. And then our constraint is going to be g of xy equal to x plus y equal to 16. But we do need the constraint to equal 0. Easy way to resolve that problem is to subtract 60 from the other side, and now it is equal to 0. And so we do plug it into our function. I already went ahead and got started here. So we take our function, which is 6x squared plus 12y squared. We plug it into here, plug directly into here. And then we're going to have lambda times g of xy. And so we see how we dragged this into right here. And so now we do have to distribute it. So we have lambda x, lambda y minus 60 lambda. And so from here, I know that I have to find the partial derivative of x, y, and lambda. So we have capital F of x. And yeah, let me move this a little bit closer. Sorry. Moving my y. Let's see. And I just left, okay. You know what? I'm just leave it there. Okay, so for f of x, we have 12x. This goes to 0. This goes to 0. This goes to 0 because they're constants. Y is treated as a constant. And so then we have this. And since we're finding the derivative of x, the x disappears or, drives out. So we have that. Then next up we have y. So we have right here 12 times 2, 24. So we're going to have 24y plus, and it looks like it's going to be the same thing again. It's going to be the y derives out, so we're just left with lambda there. And then f of lambda, this is always going to be g of x, y right there. So I don't have to, I just plug that in right there. And I know that to do algebra, I have to put these equal to 0 so I can solve for x. And we start off here, easy way to get the x isolated, we subtract lambda here. So we have 12x is equal to negative lambda, divide 12, and we end up with x equals negative lambda over 12. I should do that in green. Keep my work separated. Then next up we have 24y plus lambda. Same thing. It's going to be 24y equal to negative lambda divided by 24. Boom. We have y equals negative lambda over 24. Put our green lines around it so we know. And then now we plug these two into this formula. So we bring that over here. Not my best arrow, but we'll continue. So So we have negative lambda over 12 plus negative lambda over 24 minus 60. Okay, we gotta get the lambdas alone. So we know if we add, let me use purple. If we add 60, we get that away. So we get this equal to 60. And the way I would like to approach this is by noticing that 12 does go into 24. So if we give them a common denominator, we can combine both. We can combine like terms. And so I'm just going to multiply this by 2, multiply that by 2, and we're going to get negative 2 lambda over 24 plus negative lambda over 24, which is equal to 60. And then we can combine like terms. We end up with 3 lambda over 24 equals 60. I know also that 3 goes into lambda. So we can simplify this. Simplify, and we end up, 16 24, we end up with negative lambda over 8 equals 60. And then we go about it, we multiply by 8. We end up with negative lambda equals 60 times 8, which is 480. But we can't have a negative lambda, so we quite literally just move the negative sign to the other side. Alright, and so now we found our lambda. Lambda. Okay. And so now that we have that, we plug that into here. Okay. So now that we found lambda, we plug that into this so we can find x and y. So let me write some lines to separate out the work. Oh, it's okay. Just easily move that down. Oh. Okay, so x equals negative lambda over 12. Y equals negative lambda over 24. And so this, because this lambda is also negative, it cancels out, the negatives turn into a positive. We get this 480 over 12, and we get 480 over 24. And then after plugging this into a calculator, we get 40. And from here, we get 20. And so now that we have our x and our y, we can plug that back into our original function. So all the way up here, we finally find our x and our y's. And boom. Okay, so we have 6x squared, which x is 40, plus 1220 squared. Let me just double check. Yeah, 20. And so do the math for that. We know, I'm going to plug that into our calculator. 40 squared is 1600 times 6. We end up with 9,600 plus 20 squared is 400 times 12. We end up with 4,800. Add those together. Boom. And we have 14,400. Yeah. And then, yeah, so that's how we end up breaking it down. Go this way, go down that way. And then we start right here, connect this back down here. And so overall, it does seem like a lot, but once you break it down, I think Lagrange's method isn't too bad, honestly. And yeah. Alright, and I want to say, with Lagrange's method, I definitely struggled at first just because I feel like it was a lot to take into account, especially with lambda being added in, but I know it's the same thing as if we were to add the z. So just a little extra step, but just being cautious and breaking it all down. This is something I am for sure going to have on my reference sheet, and so I did have to put a little bit more effort into understanding this, especially now that I've gone to the office hours on Saturday, or I mean Friday, sorry. I think my understanding about this is way more better, and then I'll be able to better approach more complex questions, because I noticed a lot that a lot of the ones that we were given were x, y equals a number, not necessarily x plus y squared. When I did get an example like x squared plus y squared, I did find myself getting stuck. So I do plan on coming back to this, and this is actually a problem that I struggled with on my homework, and so now walking through this and understanding it, and then seeing how it goes down, also understanding how I get the x and the y, I'm definitely going to make sure to include this on my reference sheet, just because little mistakes really killed me in the last exam. While I did not fail, I did not get the score that I wanted, and so I'm definitely going to keep an eye out for that. And my advice to students is, just like me, literally, if you have to write out the instructions and steps to understand and know where this is going, do so. Take it slow. We are allotted 3 hours. Luckily, it didn't take me that long last time, but maybe it should have, considering I got a 75. But yeah.